Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily Leetcode problem, and the problem's name is Contiguous Array. So there will be a binary array nums that will be given to you. You have to return the maximum length of contiguous subarray with equal number of 0 and 1. Okay, so let's have a look at the constraints. I guess you would be able to understand what it means by equal number of 0 and 1. So for example, at this particular point, the number of ones and number of zeros, or let me take these things to board. Let's say this is the array given. Okay, and let's mark the indices. Okay, these are the indices. At this particular point, number of zeros and number of ones will be equal to 1. Okay, and they both will be equal. So this particular point you will see what is the length of the subarray. Okay, the length of the subarray is 2. So you will in such fashion you will find out what is the maximum length of the subarray which has equal number of zeros and ones. Okay, so this is what you have to return as your answer. Okay, and let's have a look at the constraints. The length of the nums array will be of order 10 raised to power 5, and entries in nums array can be either 0 or 1. Okay, so let's see how we will be solving this. We will be trying to solve it in the most optimal way that is possible, and before for that we will be applying a concept of prefix sum plus hashing. Okay, for that, if you are not familiar with these are two separate concepts, and these are applied in combination. So those of you who are not familiar with this particular combination or these individual topics also, I would like you to suggest you to go through a video on the channel. This is this video, binary subarrays with sum. Okay, so it is quite similar. The only difference here is for the target sum, for the goal part, you can see here that you will be having two inputs. One is the nums array, similar to what you are getting here, and one is your goal. Okay, so instead of goal, we are taking goal from our side. Our goal is to first of all, what we will be doing is, instead of zeros in this particular array, we will replace all the zeros in this particular array to -1. Okay, so -1, then comes 1, then comes 1. So this will be the modified array. Okay, replacing zeros with -1. Okay, once you do that, it will be, this whole question will be converted into this particular problem, where you will be given a nums array and a goal, and goal will be what now. If let's say number of zeros and ones are equal in a subarray, now you have converted your zeros to -1. Then if number of -1 and 1 are equal, then if you sum them, what will be the result? It will be 0. Okay, so your goal now just became 0. Okay, so you have to find out all the subarrays which are maximum length subarray which are summing up to 0. So there will be little bit modifications in this particular code, otherwise rest all of things will be remaining same. So this is, I am just introducing this video to get you familiar with the concept of prefix and hashing, prefix sum and hashing. So I have explained prefix sum and hashing here pretty well. So instead of making this video's length a longer length, I suggest you to you should go to this particular video and watch it if you are not familiar with this concept of prefix sum plus hashing. Okay, and similar concept we will be applying here. So what we will be doing is, once you have this array, I hope you have gone through that video. I will be providing the link of that video in I button. Now coming back to our problem, now we have converted our array into this kind of array where each 0 is replaced by -1. Okay, and our goal is right now 0, or targets that we are wanting to achieve is 0. So how we will be doing that? What we will do, we will be storing the frequencies of prefix sum. Let me write here prefix sum. Okay, initial value of prefix sum is 0. Okay, and let's mark the indices also 0. Then let me change color here, or I guess we should be moving it to a new slide. So -1. Okay, what was 1 and then -1? Okay, yeah, and goal was to reach to 0 in a subarray, and we were having prefix sum values. First let's mark the indices. These are the indices, and before 0th index let's assume that there is also one index which is -1, and at that particular point prefix sum value is 0. Okay, why we are taking so? Because if we show this particular array, what we will the prefix sum value here? Okay, here it will be -1, here it will be 0. Okay, so your current value of prefix sum is zero, and current value of prefix sum minus goal, what it will be? So 0 minus 0, it will be nothing but 0. So have you seen this prefix sum value before? You will answer that we haven't seen this prefix sum value before if we do not put it into the prefix sum frequency map. Okay, prefix sum, actually it will be not a frequency map. Instead of that, what you can call is prefix sum lookup, a prefix sum lookup map, you can say. Okay, or prefix sum index map, you can say, will be more intuitive to use. Prefix sum index map. Why we are using this map? For each entry of prefix sum, we will be storing the index at which this particular value of prefix sum was seen first. How this particular thing will be helping us? If let's say there is a prefix sum value of 2, let's say the numbers are something like this, -1, then comes 0 0 0, and then comes 1. Okay, and at some point you want to search for the prefix sum value of -1. Okay, you will see at all these points prefix sum value will be -1. Here it will be -1, here it will be -1, here it will be -1, here it will be 0. Okay, if you see at these points prefix sum value is -1, but if we want to make the longest length subarray, we would be interested in finding the prefix sum index at which prefix sum value was first seen to be -1, because with that we will be increasing the length in this direction. Okay, if let's say you just return the you are somewhere here and you just return the prefix sum the index at which prefix sum value was -1 to this index, then you will be having only this much length. Okay, so for for making our length longer, what we are doing is we are fixing this point and we are querying that, okay, what is the first index at which this -1 prefix sum value was seen. So it was that this index. So as you can see, the length automatically become longer as compared to this green one. That's why we are stressing on the index at which it was seen first. Okay, the index at which this particular value of prefix sum was seen first. Okay, so this is the reason. Okay, so this prefix sum index map will be storing this, and prefix sum will be of integer type and it will also be of integer type. Okay, so that's why that is also the reason that we are taking -1 as an index and adding this entry into our map. Value of prefix sum is 0 and the index at which it's occurring is -1, because here in this particular case you will be searching for prefix sum value of 0, the index at which prefix sum value of 0 occurred for the first time. Now you may see that here there was no value of there was no index at which prefix sum value was 0. So that's why we are inserting this pair from our side. Okay, so this is the reason. Now proceeding further, you will be seeing these target values, current value of prefix sum minus goal, and you will be searching for the repetition of, or let's say you will be searching for the values of index at which this prefix sum value occurred. Okay, search for the index at which this prefix sum value was first seen. Okay, how we will be deriving that prefix sum value that we will be searching for? It will be nothing but current value of prefix sum minus goal. Okay, let me change color here. So this is the value of prefix sum that we will be searching for. Search for the index at which prefix sum value was seen for the first time. Which prefix sum value we are talking about? We are talking about nothing but current value of prefix sum minus goal. So this will be the prefix sum value that we will be searching for. Okay, so in this way we will come to know the left bound of the subarray that will be summing up to 0. So we already will be having the right bound, which will be the current index that we are at while we are traversing this array from left to right direction. Okay, so let's say we are at this particular index. Now we want a left boundary. Now how can we find out this left boundary? That is the question. In for that, this prefix sum index map will be helping us, and it will give us the index of -1. Okay, so your current index value was here 1, and you find out that okay, we have seen this prefix sum value of 0 at index -1. Okay, what you will do to find out the length, you will just simply, this is your you can say, let me change color here, this is your right bound and this is your left bound, or plus one you can say to be more specific, minus one actually, not plus one. Okay, so you want to know the length of left bound and right, length between left bound and right bound. So to find the length of the subarray, you will do what? Just minus right bound minus left bound, subtract this left bound value from right bound value to be specific. Okay, and if you do the subtraction, you will be anyways getting the uh, value of the length of the subarray, that is summing up to 0, and 0 is your goal here. Okay, so I will again urge you, if you are not familiar with prefix sum plus hashing concept, to go to this particular video. In the I will be providing this video link of this video in I button, and this was one day before, or you can say two days before this video was uploaded. And in this video I am explaining the concept of prefix sum and hashing pretty well. In order to avoid this video getting longer, I am not explaining it right now, so please head over to this video if you are not familiar with this concept, otherwise you will not be understanding it at all. Or even if let's say somehow you come to understand it, then you will not be having a good understanding as compared to when you will be watching that video. Okay, anyways, I will also try to add the link of an article explaining these concepts. Okay, so now coming to the implementation part of this particular approach. This is how we are implementing it. Instead of frequency map, we should be saying that it is prefix sum index map. Okay, so that would be a suitable variable name, prefix sum index map. Okay, so what we are doing here is, first of all, we are converting each 0 in nums array. Let me increase this. Okay, converting each 0 in nums array to -1, and our goal in this particular problem will be 0. Goal is 0 here. What goal I am talking about? If you will be seeing this particular video, in this particular video, this particular function is getting an input of number, and the goal we are searching for. So this is the goal I am talking about. So goal is to find a subarray which is summing up to 0 and find out what is the length of that subarray. Okay, so in order to do so, we are using a prefix sum index map. It will be storing the values of index or indices at which storing the value of index, let you can say, at which a particular value of prefix sum was seen for the first time. I think you are no right now will be able to very well understand why we are taking uh, only for the index value for at which a particular prefix sum value was seen for the first time in order to increase our length from the left hand side. Okay, so we anyways will be fixing our length from the right hand side. Okay, this length is already fixed. We want to find out this particular prefix sum value, at what index this particular prefix sum value was occurring for the first time, in order to take this particular slider, you can say, as far as towards the left. Okay, so if it goes the more further it goes in the left direction, the more will be this particular length. Okay, this length will be increasing. If let's say it go till here, then you see for yourself that this blue one is very less as compared to this yellow one. Okay, that's why we are searching for the very first index at a particular prefix sum value was seen. Okay, so prefix sum values will be changing with each index, or we will be adding current number to the prefix sum value, and this is what we are doing here. And I already told you the reason for which we are putting a prefix sum value of 0 to be occurring at -1 index. Okay, from our side. Then there is a variable maximum sublength that we will be returning at the end. So what value of prefix sum value we are searching for? This is the value of prefix sum that we are searching for. Okay, searching for the first occurrence of prefix sum minus goal. In map. Okay, now goal is 0 here. Okay, I have just written it to make you understand what is the value of goal that we are taking. Okay, and if you have not seen this prefix sum value previously, then only you will enter it into the map, otherwise you will not do so, and at last you will be returning your maximum sublength that is there. Okay, and this is how we will be solving this particular problem. And as far as time and space complexity goes, time complexity wise, you can see that we are doing a linear traversal here. Here also we are doing linear traversal, and here also we are also doing the linear traversal. So if let's say there is a nums array and its length is equal to n, then your time complexity will be order of n. And what will be the space complexity? As you can see that we are entering prefix sum values into the map, so it will be order of n only. Okay, so these will be the time and space complexities, and this is the whole logic and implementation. If you are still having any doubts or any queries in general, then you may ask them in the comment section. Thank you for watching. Have a great day ahead.